Welcome back. How do modern systems handle background tasks efficiently without disrupting the main application? The answer lies in Async Tasks Execution Pattern. In this video, we'll explore how this pattern enables prioritized task handling, scalability, and seamless background processing. As always, what is exactly Async Task Execution Pattern? The async task execution pattern is designed to handle tasks asynchronously while allowing prioritization, ensuring critical tasks are processed first. Okay, but why does this matter? By decoupling task producers and consumers, this pattern improves system responsiveness and support efficient resource utilization. Let's look at this example to understand how it works. So, first, we have task queues. Tasks are placed into separate queues based on their priority, such as default queue and urgent queue. So let's assume this is the default queue and this is the urgent queue. Default queue for regular tasks, urgent queue for high priority tasks that need immediate attention. And we have workers here. Detected worker process pick tasks, pick tasks from the queue and execute them independently of the main application. And after that, we have task processing, like workers fetch tasks, process them, and handle retries if failure occurs. Let's take an example. An email notification system places promotional emails in the default queue and password reset emails in the urgent queue. Workers process the urgent task first, ensuring a better user experience. Okay, what are the use cases? First thing, we have background processing. Tasks like sending emails, resizing images, or cleaning up logs. The next use case for the async task execution pattern is prioritized task handling, like ensures critical tasks are executed ahead of less important ones. Number three, resource intensive operations. Delegates tasks like machine learning model in inference or data processing to separate workers. Example for that. An e-commerce platform uses this pattern to handle order confirmation emails and inventory updates. High priority tasks like fraud detection are handled in urgent queue. Okay, what are the advantages? Advantages. I can make it like that as well and delete this. Ish. What are the advantages of the async task execution pattern? The first thing, we have decouples producers and consumers, like the application producing tasks independent of the workers processing them. Number two, supports scalability, adding more workers, increasing task processing capacity. Number three, improved performance, like asynchronous processing prevent the main application from being blocked by background tasks. But each pattern has its own challenges. What are the challenges of the async task execution pattern? The first one, we have the fail tasks, like handling tasks that fail during processing can be quite complex. Number two, retries. Implementing robust retry mechanism without overloading the system. It's not that easy. Number three, queue overload. Managing task queues to prevent them from becoming bottlenecks, it's always not that easy. To solve like to mitigation to do some mitigation for these problems or for these challenges, we can use dead letter queues to capture and analyze failed tasks. We can implement exceptional backoff for retries to avoid overwhelm the system. Number 3, we can monitor queue length and worker performance to identify bottlenecks. What are the best practices? The best practice for implementing this pattern, first we need to prioritize queues, like clearly define task priorities and segregate them into appropriate queues. Number 2, use reliable message brokers, like leverage tools like RabbitMQ, Amazon SQS, or Redis for managing task queues. Number 3, monitor and scale, like set up monitoring for queue length and worker throughput, and scale workers dynamically. Number 4, ensure idempotency, like design tasks to handle retries gracefully without causing duplicate effects. So let's go to our summary. So the Async Task Execution Pattern efficiently handles background tasks with prioritization, scalability, and decoupling of producers and consumers. It's ideal for use cases like email notifications, image processing, and prioritized task handling. While challenges like failed tasks and retries exists, best practices such as dead letter queues and exceptional backoff help mitigate these issues. If you found this video helpful, don't forget to like and subscribe and hit the notification bell for more info like this. And yeah, see you in future videos.